Okay, so now that we know how to plot quadratic functions, and we've done that in the first lesson, we now have a bunch of videos on transformations of quadratic functions to go over. So a transformation is just when you move something. And so if you remember, if you took 8th grade math, you remember from 8th grade math that there are rigid transformations and then there are non-rigid transformations. So a rigid transformation is when you move something and it doesn't change its shape or the character of it other than just moving it, or flipping it or turning it or something like that. A non-rigid transformation is when you actually change the shape of it, usually by making it bigger or smaller, but it's kind of a similar thing. So we're going to look at rigid and non-rigid transformations. We really don't need to use that language with this. I just wanted to try and recall something that maybe you remembered. So the first one we're going to look at is a vertical transformation. And so if you think of what the word vertical means, right? The word vertical means, something moving up or down. So it sounds kind of like what it looks like, what it sounds like, right? You're taking this f of x equals x squared, and we're altering it by moving it up or down in a moving it in a vertical way. So let's kind of look at what that might look like. So this is we're always going to start all these videos. Most of them we're going to start with this exact same graph of f of x equals x squared. This is our parent function. In other words, this is what we reference everything to. So if we're going to do a transformation of this, let's say we say, okay, I want to move this up. All right, and so I'm going to change this to, if I figure out how to write this correctly, I'm going to change this to g of x because it's a transformation. I'm going to change the function of it is equal to basically f of x, so but f of x is x squared. And then I'm going to take f of x and I'm going to move it up. And let's see kind of what happens when you do that. Well, if you put 0 into x squared, right, you get 0. Now that we're adding 2 to it, you put 0 plus 2, right? And then that gives you a point right here. All right, if I put 1 in, it would be 1 squared plus 2, which is 3. So that's going to give me a point right here. If I put 2 in, that gives me 4 plus 2, which is 6. So I'm at the point 26. And then if I put 3 in, that's 9 plus 2, so that's 11. That's going to put me kind of like up here. So basically what's happening every time is we just took the whole graph and we just shifted it. We move the whole thing and it goes up. This continues to go up alongside of it, and this is just never gonna quite reach it, right? And believe it or not, these distances between are always going to be the same. I didn't necessarily draw it exact, but it's always going to be 2 units away if I drew this correctly, right? And you can see it here. This one you can see it's 2 units. It's 2 units away from this point right here. So it's always 2 units away. So that equation we had that said well, let's look at what it says. It says x squared plus k. If k is positive, like it is here, it's going to move it up. All right, if k is positive. And then if k is negative, it's going to move it down. So let's take a look at another one here. All right, so we're starting with our f of x equals x squared. And now we're going to say y equals -3 plus x squared. So our parent function would be y equals x squared, and then we got this -3. So let's rewrite this. All right, so it looks kind of like something, it looks like this. X squared minus 3. All right? So this is my k. All right? K is always, it's not intermingled with the x squared. It's aside from it. And you'll see when we look at our horizontal translations that it's a little different. All right, so this is my k. So that means that instead of moving this up like we did the last one, we are instead going to move it down 3 units. So I'm going to go 1, 2, 3, and I'm going to put my dot right down here. And then this one would come down 3, and I'd have a dot here. This one right here would come down 3, and I'd have a dot here. This one up here at 9 would come down 3 to 6. And then I'm going to have this graph here that never quite reaches, again, this graph. And then you're going to have, you know, the same thing over, I don't know why it's doing that. You're going to have the same thing over here with the graph where it's going to go up, right? So it's the same shape. It's the same graph basically, except that you're just raising it up or down depending upon what it is. So that's so anything that's of the form y equals x squared, if you add anything to it, that's going to move it up that many units. If you have y equals x squared and you subtract anything, it's going to move it down that many units. So that's kind of the rule. And when you do a few of these problems, you realize it's pretty easy. So good luck.